this video, I'm hopefully going to share with you something that you don't know, something that is so fundamental to ecology. It's basically like the theory of everything for biology that physics is looking for in terms of their theory of everything. It's that fundamental to the field, to understanding how life works, and it's a way to connect the physical world in terms of energy and thermodynamics to the biological, and was even proposed to be the fourth law of thermodynamics. So it is a very important principle and applies to all life. So here we go. This principle applies to complex biological systems, but it has been applied to non-biological complex systems. But we're only going to be focusing on the biological complex systems. If you haven't watched the complex systems video, I would watch the complex systems video now, or look up what a complex system is, because that is essential knowledge in general, but it's needed for this video. The maximum power principle states that during self-organization, well, actually it's not really needed, but it'll do you a lot of good. During self-organization, system designs develop and prevail that maximize power intake, energy transformation, and those uses that reinforce production and efficiency. So what does that mean? When a complex system is not in equilibrium or in a steady state, which is like a little less than equilibrium, or it is not balanced, basically, what we call balance in the hobby, it will begin to reorganize itself to enter back into a balanced state immediately, right when it becomes destabilized. It does this through, if you watch the complex systems video, you'll know it does this through feedback from the environment. It'll create new pathways, speed or slow flows of energy, nutrients, or whatever is going through the system itself that it needs to adjust. Think of it like conveyor belts going from one box of parts to another, and a constant kind of flow of building living matter and tearing it down, I suppose. And it may also adjust the size of those compartments, and it might even create new ones and new pathways. So let's check out one such model. So this is a model of an ecosystem, although this could easily model a organism as well, because an organism and an ecosystem, they are both complex systems. So they both function under the maximum power principle. The ecosystem, just like a bacteria or any other animal on Earth, will go through the same kind of thing where it will organize itself and adjust and evolve and adapt to maximize power, to increase efficiency. And maximize power is not to say to be efficient. Organisms aren't actually efficient with their energy. Ignoring the fact that we lose most of it to heat, most energy is used to maximize power. Think about it like playing a football game. It's competition out there. You're not going to win a football game by being efficient with your energy. You're going to have to pump it out. You're going to have to use what you got efficiently. So first of all, you don't burn it all up and run out of steam. Secondly, you expend enough to win the game. So it's about maximum power, not about efficiency. And this is how ecosystems develop, and this is the kind of pressure that ecosystems will place upon organisms within it, as the organisms are components within the ecosystem, the larger complex system, just as an organism's organs are components within it itself, a complex system. So the ecosystem will actually place pressures upon the organism and the organisms that most benefit the ecosystem, as far as that principle goes, will have the most success, and that's what's been observed. All right, so let's see. The design that these ecosystems are configuring to, or these complex systems are configuring to, maximizes energy throughput. Let's be specific about what this principle means. It maximizes energy throughput. That means it configures itself for four things. One, to maximize power intake. It's going to maximize the amount of energy it can take in. It wants that energy. It can use it for work to do things. Two, excellent storage of the energy. It needs a place to store the energy and store it well. Three, efficient internal feedbacks for energy recycling. These internal feedbacks are going to ensure that less energy is lost. Four, system components are configured to utilize that energy for the best use of it, i.e. the energy transformation aspect, all of which reinforce high production and overall efficiency of the complex system functioning. And that is how all life evolves, and that is the underlying characteristic of, and underlying thing that pushes natural selection. It is the maximum power principle that guides natural selection at its core. Let me see if I have anything else here. Yes. So, ecological succession is something that your aquariums go through in the first 30 days, or any microcosm of a real ecosystem, a small model of an ecosystem that I kind of specialize in. This is why cycling a tank usually takes 30 days. The process is called ecological succession, and there are a lot of different things that change within the ecosystem between the developmental stage before ecological succession, or as it's going through ecological succession, and after it has gone through succession and has entered into a stable, steady state or equilibrium. We can go through some of these right now. The gross production and community respiration ratio, P&R, very important, is greater than or less than 1 in the developmental stage. Mature stage is almost a 1-to-1 ratio. We can just go down here. Food chains before succession, this is for ecosystems, are linear, predominantly grazing. And ecological succession obviously doesn't take 30 days for an ecosystem. It's more like many, many, many years. Once it's gone through it, it's web-like, predominantly detritus. And you can see, I won't go through all of these, but you can see and pause and slow down, and you can see how the system, the complex system, radically changes. And your aquarium is an ecosystem, just like this is describing an ecosystem. The more natural your aquarium or terrarium is, the more like an ecosystem in real life it'll function. So, that is the maximum power principle. That is how ecosystems change and adapt. And that is how you should see it, as one interconnected, dependent system based upon feedback loops that is basically one thing. It is more than the sum of its parts. You should look at it as a single entity and not just what you have in the system, because it is much more than that when you put it all together.